Hi, everybody. Welcome to the last part of Chapter 12, Section 5. Let's look at the homework assignments. A line passes through the point 7, -2, -2, and parallel to the vector 5, 8, 3. Find the standard parametric equation for the line written using the components of the given vector and components of the given point at a given point. All right, here we're looking at the vector components. We're looking at this. X is x of 0, the initial point, plus t times the vector component of the first point. Y is y sub 0 plus t, the second component of the vector, and z is z sub 0 plus some scalar value vt at v3. What we see here is the point 722. Those are our x sub 0, y sub 0, and z sub 0 points. And the vector points, this is v sub 1, the components v sub 2 and v sub 3. So x is equal to x sub 0 is 7 plus 5t. Y sub 0 is -2 plus 8t. And -2 plus 3t. So those are my values. 7 plus 5t, -2 plus 8t, -2 plus 3t. Find parametric equations for the line through the origin parallel to the vector 8j 5k. So the point we're looking at is at the origin. Those are our x sub 0, y sub 0, and z sub 0. And so v1 is 0, v2 is 8, v3 is 5. So x sub 0 tv1, y sub 0 plus tv2, z sub 0 plus tv3. So x is equal to x sub 0 0 plus v sub 1 is 0, 0t, 0 plus 8t, 0 plus 5t. So it's 0, 8t, 5t. Find parametric equations for the line shown below the x-axis. The x-axis looks like that. So, and it's parallel to the vector I. Okay, so we have here v1 is 1, v2 is 0, v3 is 0. X sub 0 is 1, y sub 0 is 0, z sub 0 is 0. So 1 plus 1t and the rest are zeros. Actually, oh, if it's, don't know if that's with the x sub zeros. So no, those are zeros. It's parallel the x-axis. So it doesn't have, so it's just, since it doesn't, it's just the x-axis doesn't have a point. It's the whole thing. So it's just t. Number 4, find the equation of the plane through the point 595, normal to the vector 3, 4, 9. Okay, here we're going to use our vector component formulas. So we have our point p sub 0 at 595 and the normal 3i, 4j, 9k. We use this formula since we're looking for the equation of the plane. These are your A, B, C, and these are your x sub 0, y sub 0, z sub 0. So 3x minus 5, 4y minus 9, 9z minus 5. Distribute. We have the x, y, and z's on one side and the constant on the other side. So we have 3x minus 15, 4y minus 36, 9z minus 45 equals 0. X, y's, and z's on the left-hand side. And all the constant terms on the other side. So we have to change it. So we're adding them to both sides. So 3x plus 4y plus 9z, 3, 4, 5, 6, 7, 8, 96. And there's our equation. Okay, let's see where to put that. Using the coefficient of 3 for x, the equation of the plane through the point, type the equation. 3x, 4y, 9z equals 96. Number 5, find the equation of the plane through the points PO, QO, RO. Use the coefficient of 45 for x. So that was question number 4. Let's look at question number 5 then. PO is 5, 4, negative 4, negative 3, 4, 1, negative 2, negative 5, and 4. So let's find the equation of the plane through the point. So if we have a plane, that means we have to have the cross product, because we have to have the area of the plane. So we have vector n is going to be made up of PQ And vector V will be made up of PR. So that's -3 minus 5i, 4 minus 4j, 1 minus -4k is equal to -8, 0j, 5k. And PR, -2 minus 5i, -5 minus 4j, 4 minus -4k, -7i minus 9j plus 8k. So find the cross product of our vectors. Remember, this is the base and height. So it's made up of -8, 0, 5, -7, -9, 8. Eight, 0, 5, 8, or -8, 0, -7, -9, 8, -7, -9. We have to find those. 0 times 8 is 0, so it's 0i. -35j, 72k, minus -64j, minus -45i, minus 0k. So i's. 0 plus 45 is 45i. J is -35 plus 64. That's a positive 29j. And then plus 72k. All right, so here we have, this is our N. This is our A, B, C. And our point that we had, we can use the same room. I'm using 5, 4, -4. This is my X sub 0, Y sub 0, since that's the point in common. Plug it into here and solve it out, work it out. So we have 45 x minus 5, 29 y minus 4, 72 c minus -4 makes it +4. Right, let's continue this. Good morning. $45x. 45 is minus 45 times 5 is 225. 29y. Positive times negative is a negative. 29 times 4. 116. Positive 72z. 72 times 4. 288 equals 0. So 45x, 29y, 72z equals 225, 116 minus 288. So the only thing we have to work is on the right-hand side. That's 341 minus 288 is 53, and there's our answer. So it has a coefficient of 45 for the x, check. So we put here 45x plus 29y plus 72z equals 53. That all fits there. Number 6. Find the point P in which the lines intersect the plane. X equals 9. So we have that. Point and the line it meets. Okay, so number 6. We have x equals 9 plus 9t. Y equals -5, -10t. C equals -8 minus 3t. And the line -9x plus 2y plus 9z equals 19. We want the point on which the line intersects the plane. This is where we have to combine this parametric and these. So remember, these are the A, B, C's. And we multiply them by the x sub 0, y sub 0, and z sub 0. So we have -9, 9 plus 9t plus 2, -5 minus 10t plus 9, -8 minus 3t. And together they equal 19. Now we work it out. It's all algebra from here. So -81, -81t, -10, -20t, -72, -27t equals 19. Because here what we're going to do is now we have to find out what t is. Once we find out what t is, then we plug it back in here, and then we have our point. So let's combine like terms. -81 Negative 81 minus 10 is negative 91. Negative 91 minus just negative 163. Now for the t's. Negative 81t minus 20t is negative 101t. 101 is negative 128t. So add 163 to both sides. Negative 128t is positive 182. Switch the signs and divide by 128. They're both divisible by 2, so 2 goes into the top one 91 times, 64 times. So negative 91 over 64. That's what t equals. Now we plug t in xy in place of that. So 9 plus 9t, negative 5 minus 10t, negative 8 minus 3t. So t is equal to negative 91 over 64. Plus 9, negative 91 over 64. Negative 91 over 64. Of course, yeah, you guys use a calculator. Get a common denominator. 64 times 9. 64 times 5. Only one can be simplified would be this one. They both have an even term. So half of that one, we'll turn in 9 times 5. Half of 64 is 32. So These are my solutions. So negative 243 over 64. $295 over 32 and negative 239 over 64. Okay, the next one. Find the point which the line meets the plane. So pretty much the same thing we're looking for here. We have to plug this into the equation, the coordinate equation, solve for t, plug it into these equations, and then it'll give us a point. Number 7. The points are x equals negative 4 plus 3t, negative 2 plus 2t, negative 8t. And the line is the plane is 2x plus y minus c equals 6. Remember, these are the ABCs are in that ABCs, and these are the X's. Right. I can make sure I was right. All right, so what we have first, take 2 times negative 4 plus 3t plus 1 negative 2 plus 2t minus 1, that's the coefficient, minus 8t equals 6. Now we gotta solve for t. Negative 8 plus 6t minus 2 plus 2t plus 8t equals 6. Negative 8, negative 2, 6t, 2t is 8t, 8t and 8t is 16t equals 16. Add 10, 16t equals 16, t equals 1. Yeah, that makes it easier. So take this, plug in each one of those. Negative 4 plus 3 times 1. Negative 2 plus 2 times 1. Negative 8 times 1. Negative 4 plus 3. Negative 2 plus 2. Negative 8. Negative 1, 0. Negative 8. So that's the point in which it intersects. So it's set negative 1, 0, negative 8. Number 8. Is the line x equals that parallel to the plane, give the reason why. Well, since do we use a dot or cross product is of the vector parallel to the given line, and the normal line is given of the given plane is 0. So since that's, if it's parallel, it equals 0, then the line is parallel to the plane. So we're looking at the dot product is 0 and is parallel. That's all it's asking. I mean, that's by definition. All right, now this one. This one's a lot of work. Oh well, let's do it. A computer graphics is and perspective drawing. We need to represent objects seen by the eye in space as images in a two-dimensional plane. Suppose the eye, that's the eye, that the eye is at E1, E0, 0, as shown here. And that we want to represent the point P as a point on the YZ plane. We do this by projecting P1 onto the plane with a ray from E. The point P1 will be portrayed as the point 0x or 0YZ. The problem for us as graphics designers is to find the Y and Z given E and P1, complete parts A and B. Yeah, we need, so we're going to do the cross product here. So E is at x0, 0, 0. P1 is at x1, y1, z1. It says P is at 0, y, z. So write the vector equation that holds for E, P, E to P and E to P1. So E to P, 0 minus, so it's negative XO. I, Y minus 0, J, C minus 0, K, which makes it so then we do the same thing with E, P1. So it's X minus X sub 0, I, Y1, X1, Y1 minus 0, J, C1 minus 0, K, which means it's X1 minus X0, I, Y1, J, C1, K. So now we've write the vector equation that holds between that. Use the equation expressed. What is the correct vector equation? the correct vector equation, we have to do a cross product. So the first one's A. We want to set them equal. We'll do the dot product. We do the cross product. So that's the first one we have to do. We did that. Oh, no, we didn't. EP cross EP1. P is negative XO, Y, and Z. X1 minus XO, Y1, Z1. Negative XO, C, negative XO, Y. X1 minus XO, Y1, C1. Let's do the cross product. That gives us YC1I. X1 minus XOZ, J, negative XO Y1K. Now minus, it's going to be a plus X0 C1J minus Y1ZI minus X1 XO YK. So for I, Y, Z1 minus Y1 Z I. X1 minus XO Z plus XO Z1 J negative XO Y1 minus X1 XO K. Right, so which ones of those do we use? Use this one which has Z and Y. We can use this one because it only has the Z, which we have to look for. There's a Y. And we use this one because it has a Y right there. We're solving for X and Y, X, Y, or Z. We can't use X because there isn't one by itself. But in this fact multiplied version here, this one has both a Y and a Z, so we can't use that. So we have to use this one, X1 minus XO Z plus XO Z1. And we use this one, negative XO Y1 y, x1, x2. Set them equal to 0. Okay. So in this one, I solve for z. In this one, I solve for y. In this one, I solve for y. So y is equal to next. All right, so we can get rid of those by changing the signs here. This negative changes our sign, so we have x0, 1. So it's x sub 0 minus x1. And same thing here. Yeah. Here's the answers. So y is equal to x sub 0, y sub 1 over x sub 0 minus x sub 1. Z is equal to x sub 0, z sub 1. And those are those solutions. Yeah, so once we did the cross product, we had to look for any of those, the triple, the ijk, that had only one constant variable, either x, y, or y or z. That's what we're looking for. And that was the middle in the last one. Now the last one. Test the formulas obtained for that by investigating their behavior at x1 equals 0, x1 equals 0, and by seeing what happens as x goes to infinity. What do you find? Start with x sub 0, x1 equals 0. Good point. So we have y is equal to x sub 0, 1, x sub 0 minus x sub 1. Z is equal to x sub 0 z1 minus x1. So the first one, when x1 goes to 0, when x1 goes to 0, then it is defined. They both can be defined, but the bottom doesn't go to 0. So when x sub 1 goes to 0, then y becomes y1 and z becomes z1. If x1 becomes x sub 0, then the bottom goes to 0. They're both undefined. And then as x sub 0 goes to infinity, if x sub 0 goes to infinity, then they're just going to approach these points. All right, that does it for this whole entire chapter. Good luck, everybody. On Monday, we'll start chapter 13.